Hello, dear students. I welcome all of you in the next online lecture, that is number 6, on behalf of our college, that is Arts, Commerce and Science College, Bodhwad. We are going to study on the chapter 3 D block element for our SYBSc paper first, CH301 Physical and Inorganic Chemistry. Now in this lecture we will study about ionization energy. Ionization energy means the energy required to remove outermost electron are called ionization energy. Ionization means to form ion. When any atom is converted into ions, then we called it is a ionization. So ionization is done when any atom lose any electron or accept any electron. So when any atom lose any electron, then it form cation, and when any atom accept any electron, then it form anion. So you know there are two type of ions, cations and anions. So what is ionization? Ionization means to form ion, that is cation or anion. So this is called ionization. Now what is ionization energy? We already learnt here what is ionization energy. It is the energy required to remove outermost electrons are called as ionization energy. See in this picture, the energy which is required to remove outermost electron is called as ionization energy. So in this picture, this electron is the outermost electron. So this outermost electron requires some amount of energy, which is provided by sunlight or heat energy. So the energy may be heat energy or sunlight, or we can say photons. Photons are the energy packets of sun. So whenever this amount of energy is provided to this outermost electron get removed. This outermost electron get removed. So whatever the amount of energy is required to remove this electron is called as ionization energy. This is called as ionization energy. So when we remove first outermost electron, then it is called as first ionization energy. Now see any second electron. Consider this is the second electron. When we remove second electron, then it is called as second ionization energy. Same way, if we remove third electron, then it is called as third ionization energy. So depends on the number of outer electrons which is get removed, it is said as first ionization energy or second ionization energy or third ionization energy. So this is about ionization energy. So if we repeat, what is ionization energy? The energy is required to remove the outermost electron to remove outermost electron, that energy is called as ionization energy. See here, this electron is removed. So the energy is required to remove this outermost electron is called as ionization energy. After removing this electron, this whole atom is now become ion. Which ion? After removing electron, we get cations. And when any atom accept electron, then it forms anions. So cations are positively charged and anions are negatively charged. Okay. So this is all about ionization energy. Now ionization energy is expressed in kilojoule per mole. Ionization energy is expressed in unit what? Kilojoule per mole. So this is the definition or introduction of ionization energy. Now we will see next slide. So dear friends, have a look on animation of ionization energy. We will see a animation of ionization energy on YouTube. So see this animation. So this is the energy is irradiated on an outermost electron. This one is outermost electron. When this energy may be photon or X-ray or any heat energy. So when this energy is irradiated on this outermost electron, see, when this energy is irradiated on this outermost electron, this electron get removed. Now this electron is ejected. This is called ejection of electron. This electron is ejected. So this is the animation of ionization energy. I hope you have now understand what is ionization energy. Now see the statement here. Due to small size, the ionization energy of d block element is high. What is said here? Due to small size, the ionization energy of d block element is high. We have already studied that the size of d block element are decreasing from left to right. See, in this picture it is shown here that atomic size of d block element are decreasing from left to right. We will see it again. Atomic size are decreasing from left to right. This is left side and this one is right side. So ionization energy is of d block element is high. Why the d block element has high ionization energy? Because d block element mostly have small atomic size. All the d block element has, we will see it again, all the d block element has small atomic size. See here, if d block element or all the atom if have small atomic size, then it require what? High amount of ionization energy. If the atomic size is small, then it requires high amount of ionization energy. Now see why the small atomic size element require high amount of energy. Because if the size is small, consider this atom. This is nucleus having positive charge. If the atom has a small atomic size, then there will be a strong attraction between nucleus and outermost electron. See, if the atomic size is small, then there will be a strong attraction in between this nucleus and this outermost electron. So that's why d block element has high ionization energy, because they have small atomic size. See, all the element showing decrease in atomic size. That's why all the d block element has high ionization energy, because of being small in size. Okay, so see in this periodic table, ionization energy are increasing from left to right. See, these are S block element, these yellow ones are P block element, and these red ones are D block element. These are D. So S block element has low ionization energy, because they are bigger in size. Okay, this S block element has low ionization energy because they have big atomic size. Now D block element has small atomic size as compared to this S. So now D block element has a smaller atomic size, so it require quite a high ionization energy as compared to this S block. Okay, and this P block element has small atomic size. See here, small atomic size. These all are P, these are D, and these are S. So this P block element has a small atomic size. So because of being smallest atomic size, P block element has higher ionization energy. So what we have to say here, D block element has higher ionization energy than S block element, and P block element has higher ionization energy than D block element, because of decrease in atomic size from S block to P block. Okay, so all the D block element has high ionization energy because of these smaller atomic size. I hope you have cleared here that why the D block element has high ionization energy, but D block element has low ionization energy than this P block element. Okay, so now clear here that due to small size, the ionization energy of D block element is high. Next, so again we will see here that D block element, for D block element, ionization energy is in between S block and P block. D block element has ionization energy is in between S block and P block. So P block has highest ionization energy. This P block element has highest ionization energy, and S block has lowest ionization energy, and in between D block has moderate ionization energy as compared to S and P. That is, d block element has ionization energy in between S and P. So d block element, see here this statement, d block element are less electropositive, these d block element are less electropositive than S block element and more electropositive than P block element. See this statement, what it is state as, d block element are less electropositive than S block element. What is electropositivity? What is electropositivity? Now, what electropositivity means, if any atom lose electron easily, then it is called as more electropositive element. If any atom, again listen, if any atom lose electron easily, then that atom is called as more electropositive atom. Consider these two atoms. One has a small size and one has larger size. So, in the center there is a nucleus, positively charged. Okay. So, when any electron, see, this is outer electron and here this is outer electron. So here see, when this outer electron have to remove, so which outer electron will get removed easily? So the atom which has larger size can remove its electron easily, So this atom is more electropositive. This atom is more electropositive, while this one which is smaller in size can lose electron hardly. This atom can lose electron hardly, means it will not lose electron easily. So that's why this atom is less electropositive than this one. Okay, this atom is less electropositive than this one because of bigger in size. This one is more electropositive and this one is less electropositive because of small in size. Okay, so now the statement is d block element are less electropositive than S block element and more electropositive than P block element. See, you know that S block element has bigger size. S block element has big size and P block element has smallest size as compared to this D. So S block element has big size, that's why S block element can remove electron easily. S block element can remove electron easily. And P block element has a small size, that's why P block element can remove electron hardly. Okay, so that's why this S block element are more electropositive because it can lose electron easily, while this P block element are less electropositive because it cannot lose electron easily. Okay, what is electropositivity? Electropositivity means how readily any atom can lose its electron. That is called as electropositivity. So this S block element is more electropositive and this P block element is less electropositive as compared to D, because D has atomic size in between S and P. D has atomic size in between S and P. So S block element has a bigger size, that's why S block element can lose electron easily, and that's why it is more electropositive. And P block element has a small atomic size than D block element, that's why P block element can lose electron not very easily, that's why it is less electropositive. I hope you have understood now. So remember this, S block element are less electropositive than, D block element are less electropositive than S block and more electropositive than P block. Okay, so remember this 2 point. D block element has ionization energy in between S and P block, and D block element are less electropositive than S block and more electropositive than P block because of size, atomic size in between S and P. Now next, along the period, the ionization energy of D block element are increases from left to right due to decrease in size from left to right. See in this periodic table, atomic size are decreasing from left to right. In picture it is shown here that atomic size are increasing from right to left. This arrow is shown from right to left. So atomic size are increasing from right to left, and we can say here atomic size are decreasing from left to right. So atomic size are decreasing from left to right, that's why ionization energy of D block element are increasing from left to right. Ionization energy are mostly depend on the size of atom. So if size are decreasing, ionization energy are increasing. See this arrow. If atomic size are increasing, ionization energy decreasing. They are opposite to each other. So know this relationship. Ionization energy and atomic size are inversely proportional to each other. Ionization energy is inversely proportional to atomic size. If atomic size are small, ionization energy will be high, and if atomic size are large, then ionization energy will be low. So remember this relationship of ionization energy and atomic size. Smaller atomic size require more amount of energy to remove outermost electron, and large atomic size require less amount of ionization energy to remove outermost electron. Now next statement about ionization energy of D block element is zinc has much higher ionization energy. Why? Because zinc has completely filled 3d orbital. See, zinc has this configuration, this one. Zinc has a D10 configuration. Means zinc d orbital contain complete 10 in number of electrons. That's why d orbital is completely filled. D orbital is completely filled. and this D10 configuration is a stable configuration. What is D10 configuration? D10 configuration is called as stable configuration. So to break this stable configuration, zinc atom require high amount of energy. So if we want to remove one electron from here, we require very high amount of energy, because all the electrons are pair in this D10 configuration. In this D10 configuration, all the electrons are paired, and to remove one electron from these paired electrons, we require very high amount of energy. That's why zinc has a higher ionization energy due to what? D10 configuration. And D10 configuration is nothing but it is a stable configuration, because all the electrons are paired. See in this picture, all the electrons are paired. This is half filled, means D5 configuration, and this is completely filled, that is D10 configuration. So D10 configuration has all the paired electron, and to remove a electron from paired electrons, we require very much high amount of energy, and that's why zinc has a higher ionization energy due to this D10 configuration. Okay, now we will see next. Now see the factor affecting ionization energy. Which factor are affecting ionization energy? We have already discussed that the size of atom affect the amount of ionization energy. So first factor which affect the ionization energy is size of atom. If the size of atom is small, then ionization energy will be high, and if the size of atom is large, then ionization energy will be low. So second factor is the charge on the nucleus. If the nucleus is highly positively charged, see, if this nucleus has more positively charged, then this outer electron will be attracted very strongly by this nucleus, and that's why to remove this electron we require high amount of energy. Okay, clear? If this nucleus has highly positively charged, then this outer electron will be attracted by this nucleus very strongly, and due to this high attraction, the energy required to remove this electron will be very high. So the charge on the nucleus affect the ionization energy. So if the charge is high, if the nuclear charge, that is positive charge, is high, then the ionization energy will also high. Okay, next, screening of inner electron from nuclear charge is also the third factor which affect ionization energy. Screening effect is nothing but it is a shielding effect. See, this is a shielding effect. You know what is shielding effect? Shielding effect is a defense of this outer electron from this nucleus. See, this is a nucleus, and this one is outer electron. So outer electron, if this outer electron are getting defense from this nuclear charge, then this difference is called as shielding effect, and this difference is done by inner shell electron. See this inner shell electron. Inner shell electron has a ability to protect this outer electron from the attraction of this nucleus, and this protection is nothing but is called as shielding effect. So inner electron, if the inner electron are, see these are inner electrons, so these inner electron are protecting outer electron very strongly from this nucleus, then it is called as shielding effect. So if the inner electron has a high shielding effect, then the ionization energy will be less. The required ionization energy will be less, because inner electron are protecting this outer electron from the attraction of this nucleus. So nucleus are not attracting this outer electron very strongly, and that's why the energy required to lose this outer electron is less. Again, if the inner electron has, if this inner electron have low shielding effect or low protection of outer electron from this inner nucleus, then this nucleus can attract this outer electron strongly, and in this case the ionization energy will be high. So how effectively the inner electron are protecting outer electron from the attraction of nucleus decide the amount of ionization energy. Are you getting what is the shielding effect? What is the screening of inner electron? Inner electron has a power to defend or to protect outer electron from the attraction of this positive nuclear charge. So screening effect of this inner electron decide the amount of ionization energy. If the screening effect is high, the ionization energy will be low. If the screening effect is low, then ionization energy will be high. So see here in this picture, shielding effect is constantly increasing because there is no addition of new shell. But if we go from top to bottom, there is increase in number of shell. Here only one shell, here two shell, here three shell, here four shells. So number of shell are increasing from top to bottom. So due to increase in the number of shell, screening effect are also decreasing from top to bottom. So screening effect are decreasing, and that's why the ionization energy are also decreasing. It depends on the shell. That is, S shell has a higher screening effect, P shell, then P shell. P shell has higher screening effect than D shell. D shell has higher screening effect than F shell. So if there is a entry of F shell, then outer electron are loosely protected, and if outer electron are loosely protected, then it requires low amount of ionization energy. So shielding effect or screening effect of inner electron are also decide the amount of ionization energy. Next, another property of d block element, that is reactivity. What is the reactivity of all the d block element? See, d block element react with mineral acids. Mineral acids means HCl or H2SO4. All these acids are mineral acids. So D block element can react easily with mineral acid. Mineral acid means mineral acid always donate what? H plus ions. These mineral acids can donate these H plus ions. So D block element can accept this H plus ion. So that's why it is said that D block element react with mineral acids. So when reacting with mineral acid, they liberate H2 gas. Which gas? That is H2 gas. So few of D block element are noble. That is platinum. Pt means platinum or Au means gold. This platinum and gold is noble element. Noble element means they are inert. They are inert means they cannot react with any other acids or base or any other compounds. So platinum and gold are noble element because they cannot react with any other substance. Platinum and gold has completely filled d orbital, so they cannot accept electron or cannot donate any electron. That's why they cannot react with any other substance. That's why platinum and gold cannot react with any substance, that is air or water or mineral acids, and that's why we make ornaments, jewelry from this platinum and gold, because they cannot react with any other thing. In general, all the D block elements are less reactive. Why they are less reactive? First reason is they have a small atomic size. Why they are less reactive? Because they have a small atomic size. Due to small atomic size, they have high ionization energy. Means they require more amount of energy to remove outer electron, and that's why they are less reactive. Same way, third reason is they have high melting point. They require very high amount of heat energy to melt any element, and if they are not melting at room temperature or low temperature, they cannot react with any other substance. Fourth reason is they have high heat of sublimation due to covalent bonding. High heat of sublimation means sublimation means conversion of any substance directly into gas. Because of strong covalent bonding, they cannot convert easily into gas, and gases are very reactive. Most of the metals or substance are react in their gaseous state. So if we want to convert this metal into gas, we require heat of sublimation, and due to high heat of sublimation, they cannot react with any other substance. And why they have high heat of sublimation? Because of strong covalent bonding. Next, fifth reason is they have low heat of hydration. Hydration means heat of hydration means reaction with water. So they cannot react with water easily. Heat of hydration means the energy removed when any substance react with water. So they have low heat of hydration. See in this picture, electronegativity are increasing from left to right. Electronegativity means the tendency to accept the electron. So electronegativity of the D block element is very high. They have a tendency to accept electron. That's why it is said as they have high electronegativity. And from top to bottom, they have decrease in the heat of hydration. See, decreasing heat of hydration from left to Right. Heat of hydration means if any cation, consider manganese cation, when it react with water, when it react with water, that is it is called as hydration. So when Mn plus react with water, it lose very low amount of heat energy, and that's why this reaction is not stable, means this reaction is not possible, or possible in uh, some condition also, some condition only. So when any hydration reaction is carried out, they will produce very low amount of heat of hydration. So due to this low amount of heat of hydration, this d block element cannot react with any other metals. So this is all about ionization energy and the reactivity of d block element. So what is ionization energy? Ionization energy is the energy required to remove outermost electron. See in this picture, ionization energy is also called as ionization potential. So when outermost electron is removed by some amount of energy, then that removed electron, that is called as free electron, when require this much of energy, that amount of energy is called as ionization potential. So this is ionization energy, and when this ionization energy increase or decrease, it just depend on the size of atom. If size of atom is small, the ionization energy will be high. If size of atom is large, then ionization energy will be low. It is a vice versa relation, inversely proportional relation. So I hope you have understood what is ionization energy or ionization potential. They are mostly expressed in kilojoule per mole. And what is the factor affecting ionization energy and the reactivity. Ionization energy also affect the reactivity of d block element. So now I hope you have understand all of these properties of d block element. I express here my sincere gratitude to all of you for listening patiently. So thank you so much.